Welcome back to geometry. We are talking about chapter 4, section 6, isosceles, equilateral, and right triangles. So, we have learned how to prove triangles congruent, side, 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 angle, side, angle, side, angle, and angle, angle, side. And we've learned that we do not use the word as, because that's a bad word. So we cannot do angle, side, side. Okay? Now then, so let's learn a few more things about these triangles, and then we're going to get to that in a second. So, if you have two sides the same on a triangle, it's isosceles. And there's a thing called the base angles theorem. And what it says is that if you have two sides the same and it's isosceles, then not only are the two sides the same, the base angles are the same. They have to be. So whenever it's isosceles, the two of the three sides are the same. This third one's not the same. And these two angles will be the same, and that one won't be the same. It'll be something different. And so it's called the base angles theorem in converse. The base angles theorem is that these two angles are the same. The converse is if these two angles are the same, then the two sides are the same, and it is isosceles. Okay? Equilateral, equiangular. I sort of, had a spoiler earlier, because I told you when I taught you what an equilateral and an equiangular triangles are, is I told you then that they're actually the same thing. If something is equilateral, it is equiangular. Equilateral means all three sides are the same. If all three sides are the same, all three angles are the same. If all three angles are the same, all three sides are the same. And because equilateral is so much easier to say, we never say equiangular. It's just hard. You always just call them equilateral triangles. You probably never even heard of an equiangular triangle before geometry. Hard to say. All right. Let's talk about one other thing about equilateral triangles. Do you remember what the three angles of a triangle add up to be? That's right, 180. So if these three are x, then we would have 3x equals 180. So why is x not alone? It's being multiplied by 3. We're going to do the opposite, divide by 3. What you do to one side, you do to the other. Those cancel out. And x equals 60, because 3 times 6 is 18. So if it is equilateral, you know all the angles are 60 degrees. That's a handy little fact to know. It will be handy on the SAT, the ACT college entrance exams. That will save you time if you will just remember whenever it's equilateral, the angles each equal 60. Okay? Next idea. Okay, so here, let's use this information. Here I have two triangles stuck together into one big triangle. This little triangle is equilateral. All three sides are the same. This big triangle is isosceles. Two sides are the same. So the thing is can we solve for x and y with this information? Yes, we can. First of all, we already solved for x. We know that those angles, because it is equilateral, that these angles are all 60. Now we don't know those angles, but we know that one's 60. The other thing we know is this angle plus that one make a straight line. They make 180. So 180 minus 60 is 120. We know that angle right there is 120. Now then, if two sides are the same, the two angles are the same. So this is also y. And we know that if we add these three up, the three angles of a triangle, it's 180. So we know y plus y is 2y plus 120 equals 180. So we subtract 120 from both sides to try to get y by itself. Those cancel out. 2y equals 60. Why is y not alone? That's always fun to say, because it's being multiplied by 2. What's the opposite? Divide by 2. What you do to one side, you do to the other. So y equals 80 minus equals 30. Yes, y equals 30. I had gotten in my head e equals something else. I was like, what? Okay. Now, back to our ways we can prove triangles. Side, 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 angle, side, angle, angle, side, but not ass. Because we would just, in public school, people would be bad and eat in chemistry room. And then we would get cockroaches. And the cockroaches would come out and wave their antennas around, and we couldn't have class because we had to all just giggle about the cockroaches and scream and stuff. So if cockroaches stop all learning, you know that the word ass on the board would stop all learning. We could not learn any more math for the rest of the year if that word was on the board. So that will help you remember you cannot prove triangles congruent by angle, side, side. However, there is sort of a little exception to it, and it's if, and only if, they are right triangles. Then, if you have right triangles and two sides are congruent, then they are congruent. So see this angle, side, side. So this actually is angle, side, side, but we don't call it that because it's not for any triangle. It's only for right triangles, and we have a special name for it. It's hypotenuse leg, because the hypotenuses are the same and one leg is the same and the angles are right. Then we can prove triangles the same by hypotenuse leg. It is only allowed for right triangles, and we don't call it ass, we call it hypotenuse leg. All right? Read the book, study the examples, make sure you understand them, and I bet it's starting to get a little bit easier, isn't it? Math is great. See you next time.